Hey everyone, welcome back to Age and Education channel. Today we shall look into the chapter Acids, Bases and Salts. Okay then. So tell me, when you taste a lemon, why does it feel so sour? Why does a soap feel so slippery? And how does baking soda fix an upset stomach? The answers lie in acids, bases and salts. These are the chemical substances that are a part of your everyday life. In this chapter, we will explore their properties, uses and the chemistry behind their interactions. Right? So first of all, we shall look into acids. Okay? Now, as I have mentioned, why does the lemon taste sour? It is because of presence of some acid, right? So with that we can say that one of the properties of acids is being sour. Okay, and other substances that you can think of, what are the acids? Just think, what are all the things that are sour? Yes, tomato, fine. Then tamarind, right? Amla, okay. And what else? You can say vinegar, apples and many other things also are considered to be acids, right? And now if we get into the classification of acids, acids can be classified into organic acids and mineral acids. So what are these organic acids? Organic acids are the acids that can be derived from plants and animals, right? Acids that are derived from plants and animals are called as organic acids. And the acids that are made from industries are called as mineral acids, right? So what are these organic acids? Firstly, when we talk about the intensity of these organic acids, we can say that these are weak acids as compared to mineral acids, which are very strong acids as they are prepared from the industry, right? So these weak acids, what are the examples of it? As I have mentioned earlier, all these food items have some or the other form of acid, right? So if we start naming the acids, we can say that citric acid is an acid that you can find it in lemon and other citrus fruits, right? And malic acid is an acid that you can find in apple. Okay, malic acid in apple. These are important, you have to remember all this. Lactic acid is an acid that is present in milk and curd, right? And tartaric acid is present in tamarind, right? Tartaric acid is present in tamarind. And you can find oxalic acid in tomatoes, right? Oxalic acid in tomatoes. And last but not the least, in amla you can find ascorbic acid, right? And it is very important that you remember all these things, right? Like this lactic acid is present in milk and curd, tartaric acid in tamarind, oxalic acid in tomatoes. Don't forget about all this, right? So apart from that, we will look into some mineral acids too, like sulfuric acid. It can be written as H2SO4, right? Sulfuric acid. Then hydrochloric acid, HCl, nitric acid, HNO3, carbonic acid, H2CO3 and many other acids are, you can list as many acids as you want in this mineral acids category too. Okay, so this is about the basics of acids. Now let us get into a bit detail, right? You need not get into too much details of acids because you are in the 7th grade and you have just started getting into this taste of chemistry. You need not delve so much deeper, but we will look a bit more into acids, right? All right, we shall look into properties of acids. I know that you all can state one property without even thinking twice. What is it? S. Acids are sour in taste, right? And they have corrosive property. It is that they are corrosive in nature and they are soluble in water. Now, with this property, you can say that acids can either be concentrated acids or diluted acids. What is this? Concentrated and diluted. So, when a concentrated acid is mixed with some water, what is it? Concentrated acid when mixed with or when it gets soluble with water, it is converted into a diluted acid. So, what is it? Now, first thing I have mentioned that concentrated acid mixed with water will give you diluted acid. One important thing you have to remember here is that you should never ever take acid and pour water in it. That's an absolute no-no. You know H2O, right? Water is denoted as H2O. Okay. So, you should never ever take acid in the beaker and add directly water, because mixing of this water and acid is an exothermic reaction. It means you will find so much of heat to be released. Okay. So, when this is done directly, then it may be like lots of heat may release, and that's not good, right? So, what you have to do instead is that in the beaker you have to take water, right? And you have to add the acid drop by drop. Acid to be added slowly. So, what happens is that you will contain the amount of heat that is being released, right? So, you can happily and safely conduct the experiment you want by following this rule. Okay. Now, we are done with that, soluble in water. The other thing is, what is the other property? The other property is whenever acid reacts with any active metals. Acid, when it reacts with any active metal, what it gives? It will form a salt and give hydrogen, right? So, acid plus any metal will give us salt and hydrogen. Okay, what is the example? You can take zinc is a metal, right? And acid, you take hydrochloric acid. Okay, then what it will give? The reaction would end up like, it will give us zinc chloride and hydrogen, right? So, whenever acid, here the acid and metal, whenever these two combine, what we get is a salt, here zinc chloride, and hydrogen is released, right? So, this is another property. So, we have seen into three properties. What are those? Sorry, four. What are those? Sour, acids are sour, they are corrosive, they are soluble in water, and when acid and metal are combined, then what you get is salt and hydrogen. Okay, there are other properties too, we will look in the next slide. Okay. So, the fifth property would be whenever acid react with carbonates, what we get is salt, water and carbon dioxide. What is it? Whenever acid react with carbonates, what we get is salt, water and carbon dioxide. So, what is the example for this? When you take two molecules of hydrochloric acid and calcium carbonate as an example of carbonates, what you get is CaCl2. What is it? It is calcium chloride plus carbon dioxide plus water, right? So, this is another property. Whenever acid combines with carbonates, what we get is salt, water and carbon dioxide, right? And other property which is common to both acids and bases is that whenever acid reacts with bases, what we get is salt and water, right? So, let us take H2SO4 as an acid and take two molecules of sodium hydroxide as the base. What you get here is Na2SO4 What is it? Sodium sulfate. It is called as sodium sulfate, right? And 2 molecules of water. Okay, so H2SO4 is an acid. It means sulfuric acid, and the base is sodium hydroxide. If these two react together, what we get is sodium sulfate and 2 molecules of water, right? This is an example for this property of acids. Now we are done with the properties of acids, and now let us see how these acids are actually prepared, right? All right. Now we shall look into preparation of acids. How are these acids prepared? How are these prepared? These are prepared when you take oxides of nonmetals, which would be like carbon dioxide or sulfur dioxide, etc. When you take this and when you try to dissolve these in water, what you get is, you will get an acid, right? So oxides of nonmetals plus water gives acid, right? And these acids are specifically called as acidic oxides. Okay. Now if you want to see a real example, then consider taking carbon dioxide and plus water. What it gives? It gives H2CO3. It is called as carbonic acid. What is it? Carbonic acid. Then take sulfur dioxide and water. What you get is H2SO4. What is H2SO4? Yes, sulfuric acid. So in this way you obtain acids, right? This is the way of preparing acids. When oxides of non-metals are dissolved in water, what you get is acids, and these type of acids are called as acidic oxides, right? Fine with it? Now let us see some uses of acids. We have mentioned so many acids, right? The organic acids, mineral acids, and we should also know what is the application of every acid, right? So at least some acids we will look into the application which we use every day, or which can be very useful for us in the future too. Whenever we want to, when you are learning some science, you should always learn its application too. Otherwise it's like everything, you will just take it into your brain and you will write the exam and you leave it. Until and unless you understand the application of it, what is the use of learning science, right? That is the reason I always say, try to concentrate on application. That would be very helpful for you in the future, right? So what are the uses of acids? Let us first consider citric acid. Where can we find citric acid? Yes, in citrus fruits, lemon, right? So citric acid is popularly used as flavoring agent and as a food preservative, right? Flavoring agent and food preservative. Also, acetic acid is used as food preservative. What is it? Acetic acid is also used as food preservative. Okay. Then ascorbic acid. Ascorbic acid, you can, if at all you took this vitamin C tablets, you can see that its composition to be ascorbic acid, right? So it is the main component of vitamin C tablets. Okay. Next, carbonic acid. What is it? Carbonic acid. Carbonic acid, you can find it, or it is used to make carbonated drinks. Okay. Next, we shall look into the popular acids, hydrochloric acid, HCl. It is used in oil industry, okay, and also for the purification of salts, okay. And the other important thing is, even our stomach produces hydrochloric acid, right? It will be a milder acid, but our stomach too produces hydrochloric acid. Next is sulfuric acid. It is used in the manufacture of plastics, paints, fertilizers, etc. Okay, paints, fertilizers, etc. So I think the important things are covered, right? So citric acid is used as a flavoring agent and food preservative, and acetic acid is also used as food preservative. Ascorbic acid you can find in C vitamin. Carbonic acid is used in carbonated drinks, and hydrochloric acid in oil industries and purification of salts, and also our stomach will produce hydrochloric acid, a milder form of hydrochloric acid. And sulfuric acid is used to manufacture plastics, paints, fertilizers, etc. Okay, so with this we can say that we are done with acids, right? Now we shall look into bases. Alright, what are the bases? Bases are the substances that have bitter taste and feel slippery to touch, turn red litmus paper to blue, and whenever it reacts with acid, it will give what? What will it give? Yes, salt and water. Okay, and what are these bases as such? They are oxides or hydroxides of metals, right? So what are the examples of bases? Sodium hydroxide, that is NaOH, and this is used in soaps and detergents, right? Soaps and detergents will have this sodium hydroxide predominantly. Okay, also calcium hydroxide. So see here, you can see a metal with hydroxide, right? So whenever a metal and hydroxide you can find a combination, then you can regard it to be a base. Okay, and this is used in lime water. Okay, now okay, what are the properties of bases? I have mentioned earlier while defining the bases, right? So what are the properties? They are bitter in taste, right? Also slippery to touch, and when they react with acid, what they do? They give us salt and water, in a sense that the base will neutralize, sorry, this is acid here. A base will neutralize the acid and it will give us salt and water, right? So this is about the properties of bases, and here comes the concept of strong and weak bases. Strong base and weak base. Give me the examples. The name itself will show the meaning of strong base and weak base. I need not explain to you that, but let us see the examples, right? Sodium hydroxide and potassium hydroxide can be considered as examples of strong acids. So strong bases, right? And about the weak bases, you can consider magnesium hydroxide and aluminium hydroxide. What is it? Magnesium hydroxide and aluminium hydroxide are the examples of weak bases, right? Now here comes the concept of alkalis. What are alkalis? The bases when they are soluble in water. Bases when they are soluble in water, they can be considered to be alkalis, right? So the bases that are not soluble in water or partially soluble in water cannot be considered as alkalis. Okay. Now bases like what do you call sodium hydroxide, potassium hydroxide are alkalis. What? Bases like sodium hydroxide and potassium hydroxide can be considered as alkalis as they are soluble in water. But some other bases like copper hydroxide, magnesium hydroxide are only partially soluble in water and they cannot be considered as bases. What are those? What are the examples of they cannot be considered as alkalis, not bases. Okay, copper hydroxide, magnesium hydroxide are not totally soluble in water, right? So these are considered to be not alkalis, they are just bases, right? So where do you think the alkalis would lie? If you consider this lot to be bases, this circle to be the entire bases, only some part of bases can be considered as alkali. So what you can say is all alkalis can be considered as bases, but not all bases can be considered as alkalis, right? So this is about the concept of alkali. Now let us look into, as usual, the application part of all the bases that we keep using day by day, right? Now about uses of bases. Now let us take some bases and we will see how they are used in our daily life, right? So we will see only important applications. I don't want to overwhelm you with many things, and at last what happens is you get confused with these many things and you will leave everything. Instead of that, I will concentrate on what are the important things, right? First of all, the most important thing is sodium hydroxide. What is it? Sodium hydroxide. Okay, this is used in soaps, detergents, textiles, and even in medicines, right? See how much wide applicability it has. So sodium hydroxide. Now let us get into potassium hydroxide, right? The potassium hydroxide, you can find it in alkaline batteries, its application in alkaline batteries, and also it is used to make soft soaps. Okay, then calcium hydroxide. Calcium hydroxide, it is used to make bleaching powder, right? Bleaching powder, and to soften the hard water, okay, and also in whitewashing. These are the important applications of calcium hydroxide. And apart from that, aluminium hydroxide, one other very important base. Why very important? Because it is related to health, right? So aluminium hydroxide is used in antacids, and every person who has gastric problem will know how much important is an antacid, right? So in antacid, aluminium hydroxide is used, and also there is magnesium hydroxide. In some other type of antacid, magnesium hydroxide is also used, right? So magnesium hydroxide is also used in antacids, okay? And magnesium oxide, I haven't ever mentioned till now any oxides of metals, right? I have mentioned that the bases are hydroxides and oxides of metals. So now take this, magnesium oxide is a type of oxide of metal which can be considered as a base, right? Magnesium oxide is used in used for making refractory bricks. What is it? Refractory bricks. Even aluminium oxide, calcium oxide are also used for making these bricks, right? Calcium oxide and aluminium oxide. Okay, with this we are done with the uses of bases, right? One important thing that I forgot to mention is that, let me get into next slide. Acids, when dissolved in water, they give hydrogen ions. Dissolved in water give hydrogen ions, right? Hydrogen ions, that is H plus ions. And when bases are dissolved in water, they give, bases dissolved in water, they give hydroxide ions. Hydroxide ions, that is OH minus ions. and this number of H plus ions or OH ions will increase based upon how strong the acids or bases are, right? So with this we are done with this chapter of acids, bases, not the entire chapter, but about the acids and bases, and later we will look into salts and some other topics, right? But I don't want to continue in this video itself because it's already 25 minutes. Okay, now if you are happy with the video, you consider liking and subscribing, right? Thank you. See you. Bye.